What knowledge do you have of Jupiter, the solar system, the planet with the most satellites, a massive gas giant, the second biggest body after the Sun, and the object responsible for saving Earth from asteroids were all there? At first look, no, but in truth, scientists' perspectives on Jupiter have significantly shifted in certain respects in recent years. Start for illustration purposes with the satellites. Even when all of the planet's masses are combined, they are still twice as light as Jupiter. Given these circumstances, it becomes sense to anticipate that the gas giant should have the greatest number of satellites. In actuality, though, the first line in this race, Jupiter, took up literally a few months. The Minor Planet Center claimed of discovering 12 new moons on the gas giant in February 2023. As a result, their overall number has increased to 92, which is 9 more than the second most popular target for asteroids, Saturn. True, the joy did not endure very long. International Astronomical Union retaliated by announcing the discovery of 62 new moons on a planet with rings while still in Maya. That is an absurd amount. And there are currently 145 satellites orbiting Saturn. The majority, however, are tiny rocks with a diameter of a few kilometers. But laws are laws, and Saturn is once again in the lead in this contest, and with a significant benefit. Most of Saturn's 62 new moons, according to scientists, are the offspring of 2 once colliding bigger satellites. Additionally, this tale sheds light on another Jupiter fact that has undergone a comprehensive re-examination by experts. How on earth could Jupiter have grown to be so enormous and still maintain equilibrium with other smaller planets and the Sun? A conservative perspective predominated this issue for a very long period. And according to astronomers, Jupiter's life probably started somewhere in the solar system's past. As you are aware, there are thick clouds and a heap of building debris there. Jupiter was the furthest protoplanet when it was young. It skewed because it became so full of dust and gas. The planet slowed as a result of its frequent collisions with debris. Since gravity does not exist according to Einstein's theory of relativity, and everyone simply falls toward the Sun, Jupiter started to do the same thing as it got nearer to the star. The Earth and other planets had time to evolve during this period since they were far from the big guy. They mostly used Saturn's assistance to prevent Jupiter from killing himself. As a result, the solar system developed a delicate equilibrium, which it still has now. However, the secretive information on Jupiter's origin and motion was made public in 2022. After obtaining updated information from the Juno mission, the hypothesis that the planet's whole interior is made up of stones and dust began to fall apart. Although it would seem that if the gas giant gathered the material by its own forces on the particles, it should be a uniformly churned gravity and mush, the data indicated that the material inside Jupiter is dispersed unevenly. Reality painted a different image. In addition to gravitational anomalies, Jupiter's atmosphere only included heavy ore, as scientists prefer to put it, metallic elements equivalent to 15 to 30 times the mass of Earth. Nothing out of the ordinary at first look, but if you think about it, there are questions. Like Mars or Earth, Jupiter was formerly made of rocky material. Only after gravity got so strong that it started to suck up even gaseous substances in addition to dust, did it turn into a gas giant. The problem is, though, try throwing a little pebble from the ISS to Earth. You'll only be able to observe as it burns up in the atmosphere. It is easy to assume that a bigger rock would be needed to infiltrate the atmosphere of the gas giant Jupiter. As a result, Jupiter had to eat more than just dust and debris in order to get such a massive quantity of metal inside its atmosphere rather than on its surface. On whether Jupiter consumed other protoplanets before or after it became a gas giant, scientists are still divided. And it's not really that crucial. Jupiter can legitimately be called the killer of planets, based on all evidence and estimations. The reptiloid lizards were supposed to have designed a lot more of the solar system's initial designs, but the fat Jupiter had other ideas. Not that this issue with Earth hadn't already caused a protoplanet to crash with and partially swallow it. However, in this day and age, buildings and monuments might start to fall apart due to such a dismal past. The weather is the next fascinating topic. Jupiter is the jerk who ruins the plot in this instance. So you begin enlightening your acquaintance about the planet's changing seasons. He mistakenly claims that they are tied to the separation between the Earth and the Sun, and you laugh and correct him by saying that the tilt of our planet's rotational axis is what actually causes the change in seasons. The tilt of the Earth is around 23 degrees. We distinguish between fall, winter, summer, and spring as a result. For instance, Jupiter has no tilt. There are no seasons because of the small 3-degree axis rotation and constant heat distribution over the whole planet. The nasty friend then enters the picture. It also serves as a reminder that Jupiter's weather does in fact fluctuate, adding to the gas giant's long history of mysteries. Participating in a global project to investigate Jupiter's weather are the Chilean VLT telescope, the Void, Leo, and Juno instruments. The study's first findings unmistakably indicate that the planet's weather is changing. The crucial aspect is that they abruptly turn cyclical. It is well known that Jupiter's colder areas are lighter in color, and that the hotter a region is, the browner it appears. In fact, you can practically see this using binoculars from the ground. The only twist in this is that, unlike the Earth, the atmosphere of the gas giant causes temperatures to fall at mirror latitudes in the southern hemisphere, when temperatures rise at specific latitudes in the northern hemisphere for some reason. On a world without shifting seasons, the procedure still happens relatively instantly. There are analogous processes occurring on Earth as well. Only in this instance do they come with papers explaining tilt and how it is a necessary component of how the seasons and climate vary. It is unknown what causes a comparable occurrence on Jupiter, but possibly by studying it, scientists will eventually be able to anticipate the weather on our planet at least 15 minutes in advance. But they are the only flowers. The gas giant's moons are where the actual berries may be found. They are renowned for representing all eras of Earth's history and the process by which it became a living planet. A massive rock with a liquid core and separate magnetosphere. Additionally, it is the solar system's most geologically active body and is virtually bursting at the seams with volcanoes. Scientists believe that the frigid planet Europa has more liquid water underneath its surface than Earth does. In order to create a healthy planet with water and volcanic activity, we need to add up 3 satellites. After that, we need to let the planet a billion years to calm down and transform into a second Earth. Obviously, man's power is insufficient for it, but sufficient to make an important discovery. The most recent and intriguing discovery is that the ocean planet Europa likely lacks a core. Or it does, but it just lately came into being. We have all become accustomed to thinking of the solar system as a place where everything has been perfectly balanced and developed over a lengthy period of time. The truth, as shown by researchers from the University of Arizona led by Kevin Trin, is very different. Rock and metal make up 90% of Europa's bulk rather than water. The presence of a liquid core, mantle, and other components that are necessary for any self-respecting, distinct celestial body are refuted by the revised data on the planet's density. The new models demonstrate that, despite Europa's metal and rock being formed at far lower temperatures than the Earth, they did not necessarily dissolve, they actually froze and grouped together. Under the frozen surface, Jupiter's influence may have caused the ocean to evaporate. However, it's possible that Europa's liquid metallic core didn't exist until a billion years after the planet was formed. And the fact that it is there today is not a fact. The possibility that the satellite is still melting within and realizing its potential is not denied by scientists, which would require an additional 2 to 3 billion years, so it's feasible that we are currently observing an early stage of an Earth-like world traveling through space. Soon enough, we'll be able to say for sure. The JUICE spacecraft, which has been specifically designed to explore Jupiter's satellites, was launched in April. It will reach there and start disseminating material sometime around 2031. The aim is crucial since a different idea has become more prevalent in recent years. In the last movie, we sought out the best possible environment for life beyond Earth, but we did it by employing the conventional means: Mars, Enceladus, Europa. Forget about it. The same Ganymede may now be one of the greatest prospects for the existence of life, according to several astronomers. It all began when the Hubble telescope discovered evidence of water vapor in the atmosphere of Honey Mountain in 2021. More specifically, it occurred in 1998. But back then, people mistook water for oxygen. The finding by itself does not provide much information. On Ganymede, there is also more liquid water than on Earth, although it is primarily buried 160 kilometers below the surface. Further calculations in the tail revealed that, in principle, a third of the alternating layers of light and water could make up a third of Ganymede's circumference. And it concluded with a resounding affirmation of the existence of a complete magnetic field. Yes, it is an induced dipole and not merely a field. In fact, it is similar to the Earth. Additionally, Ganymede is the only satellite in theory to have its own magnetic field, shielding it from both the Sun's radiation and Jupiter's stronger magnetic field. We are able to make judgments about the liquid iron core and plus or minus the same processes in the interior with virtually full certainty because of how similar Ganymede's magnetic field is to Earth's. What resulted from them here then? geothermal vents that were formerly marine. The satellite may not be the most trendy, but Ganymede also possesses it, making it one of the most trustworthy locations to look for extraterrestrial life. That describes the type of Jupiter we have in our solar system and the environment it is in. Every year, the knowledge we have about the gas giant grows. However, the most important information is up next, so don't forget to subscribe, like, and comment with any queries you may have. Until then, amigos.